Good evening, team. Welcome to today's session. This is our second class with regards to this unit on Data Science and Business Analytics Foundation. And as we are still waiting for some of our colleagues to join, I just want to give an opportunity to some of the colleagues who could not speak yesterday, just to remind us what we learned. And I just want to pick one person, maybe Collins. Collins Onteri, you can just give us a recap of what we learned yesterday.
Hello, good evening. Yeah, so yesterday I was not able to join, but at least I watched the video you shared.
So sorry for that. I'm yet to know you all by name, but with time I'll be able. But you can just share what you are able to see.
Yes. Yeah, so I was able to learn that what pre-processing is, and it is let me say the way we are going to convert the raw data that we have collected from maybe the field into data that can be understood by someone else who doesn't know the specificity of that particular data. So it's just converting the raw data into something more useful. And then I also learned the different types of data. We have traditional data, which is the one that forms the basis of data analysis. And then we have big data that is mostly characterized by velocity, by it being voluminous, and then being unstructured, in that it can be audio, image, text, numeric. Yeah.
Okay, thank you so much, Collins. That is a very good trial, given that you are not in class yesterday. Maybe another person. I just want to pick Vincent. Can you add anything on top of what has been said by Collins? That's Vincent Wambua. Okay, Vincent, in case you are not in a position, maybe I can pick Jesse Mbaria. Can you add something?
Good evening, team. Maybe to add to what Collins has said, we learned yesterday about the big data, characteristic of big data, and we said maybe the following. One is variety. Maybe for big data, they have variety, volume, and what else? Velocity. And also we learned about metadata, where we said it's a behavioral kind of data where maybe a client behaves when he answers questionnaires. Yeah, back to you, Savio.
Okay, thank you so much, and especially for bringing that issue of the metadata. Like we said, metadata is data on data. Like as you have said that we are looking at someone's behavior. We are more interested in someone's behavior on how on how they are maybe completing a questionnaire and so on. So from there we are able to learn on someone's behavior, and maybe just to give something with regards to the same. Let me just pick for instance financial institutions. financial institutions, mostly, especially those that deal with maybe lending, you find out that in most cases they focus more on some kind of financial data, like maybe your mobile money statement and so on, to make lending decisions. But you see, sometimes that kind of data alone can make you to build a machine learning model that is not so accurate. And I just want to give an example. Maybe you are a manager in your organization, and you have a team, and maybe the company has sent you a lot of money via your mobile. Kennedy, maybe you can mute. Hello, Kennedy. Okay, just give me a minute. Kennedy, can you mute, please? Okay. I don't know where I was, but I think I was explaining on how misleading sometimes financial data can be if you are not keen. Like you are trying to use, you think like someone is moving a lot of money, but if you go to the bottom line, you find out that that money does not belong to him or her. So especially when you are looking at capacity, like is this person able to repay this loan and so on. So having to look at metadata sometimes is very, very crucial to assist you, like come up with a robust model that you can use to make business decisions. So another thing, I think we defined what data science is yesterday, and we saw that data science is a very wide field that entails business analytics, machine learning, big data, and so on. So today, as we introduced yesterday, what we call data processing, and as already been explained, is that this is just a process whereby you are trying to make your data or to prepare your data in such a way that it can easily be consumed by any other person who is not maybe an expert. And that is mostly what you call data pre-processing. So we have some common types of data pre-processing that maybe can happen in an organization. The first one, we have what you call class labeling of the observations in your data. As part of one of the method of data, one of the most common method of this data pre-processing. Mostly class labeling, you are talking about arranging data by category. Like you are trying to put maybe numerical data on its own, categorical data, text data on its own, images, audio, and so on. So you are trying to put your data in such a way that, like for instance, you can have an Excel worksheet. You can have an Excel worksheet that contains both numbers and text data in one column. So you see, if you give such kind of data to someone who is not an expert in this area of data science and so on, they might struggle to work around that one. And therefore, you can use various functions or formulas found in various data science software to ensure that you are able, first of all, to extract if one column of data maybe contains text alone, another column contains maybe numerics and so on. Maybe I can try to demonstrate. Let me open an Excel workbook and try to demonstrate what I mean. Let me open an Excel workbook here. Hello, guys, can you hear me well? I see there's a complaint. Can you hear me in real time or there's a delay?
We can hear you in real time.
Okay. I think Mr. Michael, maybe you can leave and rejoin again. Okay. Maybe we can continue. Let me share this Excel. Okay. Let me share. I just want to demonstrate what I mean, but on how to do it, it will be done in another unit. So let us say you are having an Excel workbook and maybe you are having your admission number. So this is what I mean. So you see in this column A, in this column A, maybe you are having your data both in numerical and text format. And maybe you are interested to have numerical alone in column A and text data in column B. So that process whereby you are trying to separate the two is what you call a class labeling and so on, which is part of data preprocessing. So you find out, for instance, if one, we know in organizations we have admins, right? So it means that not everyone can apply an Excel function to be able to split the two. So it's how to work around it easily. Okay, so you can continue. Another one is called what you call data cleansing, data scrubbing. So this one mostly happens when you are dealing with, sorry, I don't know if you can see my presentation. Just a minute. Okay. The next one, we are talking about data cleansing, or what call a data scrubbing, which is also part of the data pre-processing. So in this case, you are trying to deal with inconsistent data. Uh, for instance, in case you have misspelled categories in your data, you are having missing values and so on. So your work is to assist on how you are going to address such and so on. And you will be learning this mostly in the statistics and machine learning units because, as said, most of the data that we normally use is not, it will always have these issues, especially the data that you're using to build the machine learning models and so on. And data pre-processing, you have to know how, first of all, are you going to address missing values? How are you going to address misspelled categories and so on? So data cleansing, and it is part of uh, data pre-processing. Another one, another common data pre-processing method is what we call data balancing. We are talking about data balancing. This happens mostly if the categories in your data have what we call an equal number of observations. It means that it is not representative of the population. And therefore, if you continue implementing an analysis without working around this, it means that your final outcome, like the decision that you are going to make out of the your analysis results, might lead to misleading kind of information like business decisions and so on. So you need also to look at what we call data balancing. It is very important. So this mostly, as I have said, it contains, like, it happens when you have an equal number of observations in your data, and therefore, what are the implications? The implication is that if you have an equal number of observations in your data, it may not be representative of the population. So it means that even your analysis, if you proceed to do any kind of analysis, your results might be inaccurate. And therefore, that one also needs to be addressed. Another common data pre-processing method that you'll be meeting or doing it practically when you reach there is what you call data shuffling. So basically, data shuffling, you are looking at rearranging your data points. Mostly, the objective why you need to rearrange your data points is to remove any unwanted patterns. And by removing these unwanted patterns, it means that you are improving your predictive performance and so on. So it is something also that is very common. You will come across it as you do it practical. But as we said yesterday, this first unit mostly is just to give you an overview theory of what you're expecting, so that when you reach there, when this term comes again now, and when you do practical, you know at least the theoretical part of it, like you have some kind of prior information on what you are supposed to do. So it is a very, very common kind of a data pre-processing method we do have, or you will come across working as a data scientist, a data analyst, or a data engineer. So it is something very common that you'll come across. Another one is what called data masking. So the last topic, if I'm not wrong, under this course one, we will be talking about data privacy and governance. And this is something that has become so serious. And I hope we all know the issues of data privacy. Various jurisdictions, like in Kenya, already we are having the Office of Data Protection dealing with that. In Uganda, the last time I checked, I think they were setting up, but when we reach there, I'll be looking forward to hear from Belinda more of what you are, to give us more information of what is happening there with regards to that, and also other jurisdictions across Africa. We'll be interested to hear what are happening from our colleagues, those who are outside Kenya, and so on. But when we are talking about data masking, this mostly happens in big data. And the objective of data masking is to ensure that any confidential information in the data remains private, but without hindering the analysis and extraction of insight. Like you are trying, the main thing when you are talking about data masking here is that it involves concealing the original data with either random or false data. And the objective of this is just to allow the data scientists to conduct their analysis without maybe compromising on private details. You know, sometimes in organizations we face challenges, and as much as we have data privacy policies, as much as we have installed a lot of security measures in our laptops and so on, but you see, that one does not prevent someone from taking someone's data and so on. And I know, for instance, banks, in banks also they ensure that they have maybe CCTVs. So in case you try to do anything, it is being monitored. But suppose someone can maybe, let me say, internalize someone's confidential details, maybe that you can memorize using your brains and walk away, then share later. Does it mean the data privacy will be compromised? Of course, yes. So, as employees, of course, we understand that we do have contracts that and organization policies or bylaws that ensure that employees do not conceal, so do not share any kind of personal data without consent and so on. But at the same time, we see that when we look at the bottom line, the issues of data privacy, especially in organizations, it will, like the decision maker on how to ensure that the data is private, is that kind of employee, not the systems, because the systems are never secure. They are never 100% secure. Data can still leak and so on. So it is something we will discuss on data strategy and governance. I think it is the last subtopic here, and it is always a very interesting part of this specific unit. But as part of data pre-processing, data masking also is very important. You can always try to conceal those information that you think can be used to identify someone, but at the same time, concealing does not mean it is going to compromise with the quality of the analysis and so on. So Those are the most common data pre-processing methods available. Maybe just a recap. I have said the first one is class labeling of the observations, like you are trying to put your data into categories. The second one, we have talked about data cleansing. Data cleansing, the main objective, we have said that it is used just for the purpose of ensuring that your data is consistent. We have talked about data balancing. And when we are talking about data balancing here, we have said that in case you have an equal number of observations, it may be not be representative of the population. So you need to try to balance your data, like to try to extract an equal number of observation for each category before you proceed with further analysis. As well, we have looked at what called data shuffling. And this data shuffling, we have seen mostly it involves rearranging data points to eliminate any kind of unwanted patterns and improve um, predictive performance. We went further and looked at data masking. Data masking, we have said that the objective is just to hide the identity, to hide the information that can identify a subject, what you call a data subject or a person, or anything that is so confidential. And as we have said, the objective of this is not to compromise on the analysis. There is analysis, outcome, and so on will remain the same, but it's just to protect the information of someone. So that is some of the common items on or methods with regards to data pre-processing. So the next question is, where does data come from? This is the next question that we want to answer. Where does this data come from? So yesterday we looked at two kinds of data. We talked about the traditional data and we talked about what we call big data. We talked about traditional data and we went further and looked at what we call big data. So, uh, in terms of sources of data, also, where does this data come from? We will look into it by looking at, first of all, the traditional data, then we look at the big data. So, one of the areas, and I think I gave out an example yesterday in an Excel table, and I say that I'm very sure majority of us are dealing with traditional data in our organizations, even up to date. And as we see that this traditional data may come from basic customer records or some kind of historic stock price information and so on. When we are talking about, for instance, the basic customer records as part of the source of the traditional data, these customer records can contain information. We are talking about basic customer records as part of the source of the traditional records can contain information. One, it can contain customer ID. It can contain maybe the frequency that the customer has filed a complaint, maybe with that organ. Maybe the amount of money spent in a single purchase by a customer, and maybe the address of this customer, the contact information, and so on. So you have seen that one of the sources of traditional data maybe it's just the basic customer records that you have in your organization, and maybe historical stock prices and so on. But we can have various, it depends with the industry that you are working. But one thing that you to understand about traditional data, as we said, we say that traditional data is structured and it is represented in a table format. That now gives you the definition of traditional data. And most organizations are still handling traditional data, and these traditional data are mostly stored in relational database and in a single compute. Meaning that it is not like big data whereby it is stored in several computers and so on. This one, so that let me try to check my internet. Thank you, Colin, for that. Just a minute. Oh, maybe Vincent, what you can do, you can leave and rejoin again. In case you can't hear me well, you can just leave and rejoin. Okay, thank you. So I was explaining um, on traditional data, and more specifically here, I was looking at the sources. The main question was, where does data come from? And we are looking into it by classifying again our data into traditional and non-traditional, or what you call big data. And we have said that this traditional data, it may come from the records in your organization or any kind of historical stock price and so on. And I went further and said, like when you are talking about customer records, what are the fields or the columns that you can have in your customer records? One, we said you have the customer ID, maybe the frequency in terms of how many times a customer filed a complaint with your organization, maybe the amount of money this customer has spent per purchase, and other details such as the contact address and so on, or the contact information. And when we are talking about maybe the historical price of stock or shares, maybe you can mostly look at how that one, you can have the dates of the observation field, the names of the stocks and their prices and so on. So that is also part of more explanation with regards to that. So this is with regards to traditional. So maybe we can look at it also with regards to non-traditional data, or what you call the big data. So I hope you have been very keen on the images that I have been using on my slides, because I use them intentional to communicate. So we can see that in terms of where does data come from, in terms of big data, we can see the image of a phone there with social media, Facebook, and so on. Mostly, we have seen that a large number of growing, like these companies and industries, uh,
I've started using what you call big data,
have started
and they are
using
not
what you call
using it
big
alone,
data, and they are
but
not
they are
using it
generating
alone, but they are
this
generating
big
this
data.
big
And
data.
especially
And
when we are looking
especially
at these
when we are
online
looking at these
communities,
online
we
communities,
have Facebook,
we have Facebook,
we have Google,
we have Google,
among many other
among many other
online community.
online
You find out
community.
that
Find
they
out that
generate a lot of
they
big
generate
data.
a lot of big data.
Also,
Also,
we have what you call machine data,
we have what called
especially from
machine data,
sensors
especially from
in various
sensors
industrial equipment,
in
also
various
amounts to
industrial
big data.
equipment, also
Then we have
amounts
what
to
called
big data.
wearable tech.
Then we have what called
These ones
wearable
mostly,
tech. These
maybe you
ones
can have a
mostly,
gadget like
maybe you can
that
have a
looks like
gadget that
a
looks like
watch that maybe
a watch
collects temperature
that
in your
maybe
body
collects
or tries to
temperature in
measure
your
your
body
body
or tries
pressure
to measure your
and so
body
on,
pressure
and
and so
converts
on
this data
and conveys
in
this
real time.
data in real
Those
time.
are what called wearables.
Those are what called wearables.
So one thing
So
that
one thing
is
that
amazing, if I can say, is
is
that
amazing, if I
currently,
can say, is that currently,
like
um,
when we are
like
talking about the volume of
when
this
you are talking
digital
about the
data, it
volume of
amounts to
this
what called
digital data, it
to
amounts what
3.2
called
zegabytes.
to
And
3.2
the
zegabytes.
most
And
interesting
the most
statistic
interesting
here is
statistic
that
here is
90%
that
of this data
90% of this data
has been
has
generated
been
in the last two
generated in
years
the
only.
last 2 years only.
In the last 2 years
In
only,
the last two
we
years
have
only,
generated
we have
90%
generated
of
90%
digital
of
data.
digital data.
So the big question
So
is
the big question
maybe
is
how
maybe
can
how can
organizations capitalize on
organizations
this?
capitalize on this?
And you are going
And
to answer
we are
all
going
those
to answer
questions
all
as we
those
proceed
questions
by.
as we
Like how
proceed by.
can
Like how can
companies
companies
use
use
this data
this
to
data
try and
to try
improve
and
business
improve business
processes
processes
leading to
leading to
increased revenues.
increased revenues.
So,
So,
um,
um,
first of all, let me
first of
just
all,
come
let
back
me come back
again
again
so that
so that
you are able to
you are
know
able
how
to
we are
know how we are
progressing.
progressing.
We have looked at
We have looked at
pre-processing
the
of data,
processing of data,
and we have
and
said
we
that
have
it's just
said that it's
preparing
just
this data
preparing
for
this
further
data for further
analysis.
analysis.
After that,
After
we have
that, we
looked
have
at where
looked at
does
where
this
does
data
this
come
data
from,
come from.
and
And
in in
in in
in this
in
one we have
this one, we
looked
have
in
looked
form
in
of
form of
traditional data
traditional data
and
and
big data.
big data.
Now the next
Now the
question:
next
who
question: who
handles the
handles
data?
the data?
Who
Who
handles
handles
the
the
data? We have
data? We have
known
known
where it
where
comes
it comes
from,
from,
but
but
now
now
who
who
handles
handles
the
the
data?
data?
So,
So,
in
in
terms of
terms
who
of who
handles the
handles the
data,
data,
the
the
first
first
person is
person is what
actually
called
data
data
architects.
architects.
So
So
these
these
people,
people,
uh,
uh,
they
they
deal with
deal
what
with
you call
what
raw
called raw
data
data
and
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 pre-processing,
pre-processing,
and
and
mostly
mostly
they
they
work
work
with
with
creating
creating
databases
databases
and
and
maintaining
maintaining
them,
them,
maybe by
maybe
a
by a
different
different
name and
name
so
and so
on.
on.
A
A
database is
database
where
is
you
where you
store
store
data in your
data in your
organization.
organization.
So
So
these
these
people called
people
the
called the
data
data
architects,
architects,
they
they
specialize
specialize
in
in
dealing with
dealing
raw
with raw
data
data
and
and
pre-processing
pre-processing
it.
it.
In
In
most
most
cases,
cases,
their
their
role
role
ends
ends
there.
there.
But
But
sometimes
sometimes
data
data
engineers, it
engineers, it
depends with the
depends with the
organization, as I
organization, as I
said
said
yesterday,
yesterday,
that
that
it
it
keeps
keeps it
sometimes they
sometimes they
interchange and
interchange
so
and so
on.
on.
Sorry.
Sorry.
Okay,
Okay,
sorry
sorry
for
for
that.
that.
So,
So
there's one
there's
thing
one
that
thing that
is
is
very
very
interesting.
interesting.
We see
We see
that
that
the when
the
we are
when
talking
you are talking
about
about
data
data
architects,
architect,
these
these
people
people
create the
create the
databases
databases
from
from
scratch,
scratch,
like they
like they
design
design
um,
And when you will learn that SQL unit, you will do some of this data architect. Like you come up with, if you want to collect your data, maybe in form of a table, you design first, you set your fields and so on. So that is one of the things that you will look into as part of data engineer, like designing. You'll be trained on how to do so using, I think, SQL. And so these people, uh, you create a database from scratch. So what does it mean? When they create the database from scratch, it means they design the way data will be retrieved, how it will be processed, and how it will be consumed. That's the role of these data architects. Like they design, uh, they create databases from scratch. That means they design the way data will be retrieved in organization, how this data will be processed, and how the data will be consumed. But when we are talking about data engineers, a data engineer now will use the data architect's work as a stepping stone, and they pre-process this available data. The data engineer in an organization, they are the ones who are responsible to ensure that the data is clean and organized, and it is ready for those analysts to take over. I want you to get it very clearly. As I say that sometimes, since the African market with regards to data and so on is still, it has not yet matured, if I can say. So there's a lot of confusion in terms of roles on who exactly the organization wants. So there's a difference, but I said further yesterday that it depends. Like organizations that do not have adequate kind of budgets, they might hire just a data scientist to do everything, or they hire what you call data analyst developer, you do everything, and so on. Like data engineering, data architects work, and so on. So I want to go back so that you get it very clearly. These data architects, as we have said, they create databases from scratch. They design the way data will be retrieved, maybe from the system or database, how it will be processed and consumed. But when we are talking about a data engineer, their role is mostly data pre-processing. They ensure the data is clean and organized and ready for analysts to take over. Then after that, another person called database administrator comes in. The database administrator controls the flow of data into and from the database. So there's a data architect, there's a data engineer, and we have a database administrator whose main role is to control the flow of data into and from the database. But nowadays, as we have said, that as a result of emergence of big data, this role of a database administrator, like the role of a database administration and so on, is almost automated. Like there's no real need for a human administrator nowadays because of the emergence of big data and so on. The process can be uh, automated, and there's no need to have a database administrator. And because the main reason it, it is said so is because the database administrator deals mostly with traditional data. And traditional data, we have seen it is in a table format, more organized. But when we are talking about big data, we are talking about data that is unstructured and so on. So this data needs to be collected in real time because of high velocity, it is voluminous and so on, and also needs to be processed in real time. And in most cases, sometimes in some organizations, as a result of big data emergence, a data engineer does this role, the automation process. So we will look further again, where now we look at various roles in data science, business analytics, and so on. But I think before we go to our break, that's our 10-15 minutes break, I want to give room for questions. We started on pre-processing. In case you had any question or anything that you need to be clarified, you can raise up your hand and ask. Then we looked at where does data come from. After that, we looked at who handles this data, mostly in organizations. Before now, we look at data science explaining the past. Questions? And any questions, in case you have any question?
I think I'll just ask the question straight up.
Yes. Yes.
It's not more of a question, but rather a wonder in terms of the future capacity for holding the data, going by the fact that the rate at which data is churned out. I don't know to what scope of technology we are headed, or perhaps there's no need of memory per se. I'm just wondering, where would this big data sit that retrieval and exchanges on an instant and that fast, going by the capacity of the technology where we are right now?
Okay.
I'm just
Okay.
wondering. I don't know.
Okay. Thank you so much for your question. So nowadays, because as we have said that this most organizations are still um, like most organizations are still dealing with structured data, and they are stored in what we call relational databases. There's what we call nowadays a data lake. I understand. Okay, there at some point there was one of our students that we were assisting in setting up a data lake. Like a data lake now has the capacity to hold this data, and a data lake, it stores and processes secure and large amounts of both structured, semi-structured, and unstructured data in organizations. So companies are moving from relational databases to data lakes, but also I'm aware, like you have talked about capacity. If I look at mostly the financial industry, especially the banking sector and other financial industry, there's if I'm not wrong, most of them are required to have the internal, like this data must be stored internally and so on. So what it means is that these organizations have to spend a lot of money to build these data lakes that store both structured and structured data, because the relational databases that we are having cannot accommodate it. So the solution is organizations to invest in data lakes that store both structured, unstructured, and semi-structured data. I don't know if that is clear, Caleb.
Yeah, yes, it is.
Okay, thank you so much. Any other question? Okay, we can proceed to, I think 10 minutes is sufficient instead of 15. We come back at 9:10 East African time. No, it is already 9:02. That's 9:12 East African time, Nairobi time. So we can go for a break, then we come back after 10 minutes. Okay, so let us look at the last part of today's session. As I said, I like my sessions to be always brief so that you are able to digest whatever we have gone through. And as I said also, I shared the PDF version. You'll check in your emails, respective emails, the notes that I'm using for this class. Additional materials will be shared after the unit. So I want us now to look at data science explaining the past. Data science explaining the past. So data science explaining the past is what you call business intelligence. So when you are talking about business intelligence here, so there's a way, or what you can say, we have two ways of looking at data. The first one, we are looking at the data with the intention to explain the behavior that has already occurred, and you have gathered data for it, or you are trying to use the data you already have in order to look at the future, or what you call predictive analytics. This is the behavior that has not yet happened. So we have two intentions here. One, you have data and you want to see what has already happened. Like for instance, if you sell some products, or you collect some data and do analysis of what has already happened, but at the same time you can look at what might happen in future, what is called predictive analytics. So, but before we look at what we call predictive analytics, like what might happen in future, you must first of all look at the patterns of the behavior of the past, analyze them to draw insights and inform the path for forecasting. Like, first of all, you have to look at what happened in the future, what happened in the past. you have to do some kind of a deeper analysis, and this one will assist you to draw some kind of insights and inform the path for forecasting and so on. And therefore, we are talking about the primary role of business intelligence is to try and look at the patterns of the past behavior, do some kind of analysis, draw insights, and therefore, after you find these insights, those insights are the ones that can assist you on the kind of path that you are going to follow in terms of forecasting. So, in terms of maybe an example, when you are talking about business intelligence, business intelligence mostly focuses on providing what you call data-driven answers to some of the questions. Like for instance, in business intelligence, might be interested to know if you are selling, for instance, products, how many units were sold. After that, business intelligence might also want to know in which region were the most goods sold. Then, which type of goods were sold and where. In terms of marketing, for instance, you are talking about how did the email marketing perform last quarter in terms of maybe click-through rates and revenue generated. Also, maybe you might be interested to know that how does that, like you're talking about maybe email marketing as part of your marketing strategy. For this time, how does it compare to the performance in the same quarter of last year? So you see that business intelligence mostly tries to answer questions on what has already happened. And we can say that business intelligence is part of data science. Like, yes, we are saying that it does not have data science in the title or its title, but business intelligence is part of data science. And therefore, yesterday when we are defining data science, we say that this data science is a very wider field that cuts across data analytics, predictive analytics, and machine learning, artificial intelligence, among many other. So, as we have seen that the main role of business intelligence is to try and explain what happened in the past. And you have seen, like for a case of a sales department, for instance, you have seen that those are some of the questions that it tries to answer on what happened in the past. Therefore, that leads us to a person called a business analyst in the organization. And what does this it is business intelligence analyst, not business analyst. Those are two different kind of people. The difference when we are talking about a business analyst in organizations, these are people who try to they try to study various processes in organization and come up with recommendations on how to improve, and maybe to try and come up with new opportunities and so on. Those are business analysts, which is totally different from a business intelligence analyst. So we want to see what does a business intelligence analyst do in an organization. As you have said that it is part of data sciences, it doesn't have the name of data science in it, but it is part of data science. One is that we have seen that this can be used, they can be used in terms of assisting the organization to measure business performance. But for this person called a business intelligence analyst to be able to achieve what the organization intends them to do, or to achieve their key performance indicators and so on, these people must employ specific data handling techniques as a business intelligence analyst. So the first thing, as you have seen, is that the starting point of all data science is data. Like, that is the starting point, irrespective. And yesterday we gave a certain scenario. We gave two use cases. The first case, this person had ready data. The second case, this person did not have any kind of data. So there were two kind of cases. And we saw that all that you must have data. That's the starting point of all data science is data. So, and it is not just about data, it must be relevant data. Because we saw yesterday that the most important thing as a data scientist is for you to understand the business problem. Like, are you able to understand the business problem that you are facing and formulate questions and so on? So once the relevant data is in the hands of this business intelligence analyst, for instance, you are talking about monthly revenue, number of customers, sales volume, and so on. So this person must quantify the observations, calculate the key performance indicators, and try to examine and measure this to extract insights from the data. So, as you know that data is about telling stories, that's the end goal. So, apart from handling, now here we go to presentation skills. And maybe for those who are working among you and you are in maybe a senior position and you do get an opportunity to go and present in the management meeting or board of management meeting, you know how, because management meetings is for, they are for decision making. Like, the board work is just to make decisions based on what is there. So it means that you must be very good in communication as well. So we see that apart from handling this numerical information, a business intelligence analyst is supposed to visualize the findings and create easily digestible images supported only by the most relevant numbers. So, yes, we have that technical analysis. You can write your Python codes and so on, but no one in the management is interested. They are interested to see something simple that can be easily understood by anyone. So, meaning that when you end up being a business intelligence analyst, all levels of management should be able to understand the insights from the data and inform their decision making based on your analysis. And therefore, what these business intelligence analysts do, they create dashboards and reports. And that's why you need Tableau, because it is very good in creation of their dashboards and reports. And these dashboards and reports must be accompanied by graphs, diagrams, maps, and other kind of visualizations that can assist to present the findings relevant to the current business objectives. That's why you see here, first of all, you must quantify your observations, then you must calculate your KPIs. Like, the questions that you are trying to answer is what should appear in your dashboard, what you are trying to explain, such that it can be easily understood by those people in management. So we have seen that business intelligence looks at, it is part of data science. That's one thing we have learned. Secondly, we have learned that business intelligence mostly tries to look at what happened in the past in the business. And another thing is that there's now someone who is called a business intelligence analyst. Their work, mostly apart from analyzing the data, they are supposed to communicate in a simple language that can be easily understood. So for today's session, I don't want to go beyond what does a business intelligence analyst do. Tomorrow we shall start from where is business intelligence used or applied in organizations. We are going to pick just some. It is now time. I just want to give you an opportunity to ask some questions. Then after that, I think we can close there as I'm uploading the recording so that I can share in form of a video, a link which is easy to access it at any time. Can we have any questions in case you are unable to ask? Also, you will check your emails. If you haven't received the notes, you can just inbox me. Maybe just a quick recap as I'm waiting for your questions in case you have any. We started from data pre-processing, and we have seen this is just preparation of data for future analysis. Then we looked at some of the items that you come across in data pre-processing. We talked about class labeling. We talked about data cleansing. We talked about data balancing, data shuffling, data masking. Then we looked at where does data come from, and we looked under two angles. One, traditional data, and we looked in terms of big data. After that, we looked at who handles this data. We looked at data architects, and we said that these are people who create databases from scratch. After that, we looked at data engineers. We say that data engineers mostly, they are responsible for data pre-processing. And then we looked at database administrators. We say that they control the flow of data into and from the database, but we have come to learn that with the emergence of big data, this role is almost becoming redundant. And therefore, we had a question from our colleague Caleb, who said that yes, there's a lot of data that is being produced. Where are we going to store all this data? And I responded by explaining the issue of data lakes. Then we have closed by looking at data science, explaining the past, and we have started with what we call business intelligence. And you have said that business intelligence is part of data science. And further, we have looked questions that a business intelligence analyst tries to answer. Then there's this person called business intelligence analyst, and we have learned that the critical thing above all is communication in a simple way that can be understood by anyone. Yeah, I think that is where we have ended today. I want to give Naomi this opportunity to ask your question.
Okay, thank you very much, Xavier. Sorry, just to take you back. I just wanted to understand the exact difference between the business intelligence analyst and the business analyst. And what kind of data then does a business analyst interact with when you're talking about processes as opposed to a business intelligence analyst?
Okay, thank you. So a business analyst does not in does not really deal with data, like data in most cases. Yes, there's, as I said, there's a lot of confusion that even organizations are unable to differentiate between a business analyst and a business intelligence analyst. So business analysts mostly in organization, they try to study at maybe processes, like they have a general overview of the business and try to do some kind of analysis and identify opportunities that the business maybe can, in terms of maybe if there are new products and so on that a business can try to venture into. And I want to give another example with regards to business analyst. I don't know if we have anyone here. There was one of our colleagues who works at TransUnion. I think he's not in today because he's in the ICT. So suppose your organizations wants to purchase a new system or implement a new system. Remember, for any new system that a company implements, there is a lot of cost that will be incurred. So a business analyst will try to assess, do some kind of like cost benefit analysis. Like they are trying to see this a new system that you want to implement. What will it cost it us in form of resources, in form of uh, what else? In form of resources that we need to incur, and what are the benefits. Then after that, they can advise if there's something viable or not. And especially when you are working in a very serious IT projects, you do find out there's a project manager, there's a business analyst, and maybe now the software engineers and so on. So business analysts they look at overall processes in a business and try to advise, as compared to a business intelligence analyst who deals with data, mostly historical data, and try to answer what happened in the past. So there's a clear distinction between the two. However, I must accept that there has been a lot of confusion on between the two categories. So I don't know if that is clear, Naomi.
Yes, that is very clear. And just so that I don't raise my hand again, when you were talking about data shuffling, saying it's just rearranging data to eliminate patterns, does that interfere with the trend of the data, or maybe will I get to see it practically to understand?
No, it doesn't interfere with the trend of the data. In fact, it is used to improve, to make your model more accurate, as compared to leaving it like that, which can give you more inaccurate model. But you'll do it practically, as we have said.
Okay, thank you.
Okay. Maybe another question. Okay, maybe I just want to pass a message. First of all, in case you haven't completed the admission process, I think you can, I'm sure there's someone from operations who has contacted you, because the returns are normally resubmitted to IBAC. That's the final list and so on. So in case you haven't, just try to check on the communications from AFRI's DSA team. That's the operations team. Secondly, during our first orientation class, I said, in case you are unable to attend a class, let me know in advance, because also still records we take to IBEC on the class attendance. Then the last thing is that I shared a calendar invite for this class. And so far, I think out of 23 students, 16 only have accepted. So the internal policy is that you are required to accept it so that I don't have to be sharing the link over and over again in the group. You just go to your calendar, click, and join the class. Yeah, I think those are the items that I had from my end. Before you sleep, you will have the recording for today's class. So thank you all for attending today's session. In case of anything, you will let me know. So thank you and have a good night.